So, binaural mixing. First, we really need to find out what the difference is between stereo and binaural. So we've done a bit of stereo already, and we manipulate stereo through the movement of both the volume and the pan. So we can pan a sound from the left to the right, and we can increase or decrease the volume to create the sense of distance and position. But stereo only works on a flat field, a flat bed, 180 degrees. And so we have our, this is actually a balance. I'll go into it in more detail again, but if I click on stereo out and select stereo pan, that is different because it works like that. And I'll talk about that in more detail in a later little clip. But for now, that is stereo pan as opposed to balance, which is what we've been using up to now. And so yes, so stereo, basically most music exists on a horizontal plane. We tell distance and position through the manipulation of pan and volume. Binaural is somewhat different. So I'm going to click on this now, low Atmos, and I'm going to go to stereo out, and I'm going to select Binaural Panner. And as you can see, the little icon has changed. If I double click on that icon, you get something that looks like this. And I'm just going to explain the functionality of this before we get into mixing for real. So it depends very much on whether you have, I'm going to do the same for the clown voice. I'm going to select stereo out and binaural panner and open that up. And I did this just to show you the difference between a mono source, which is a single mic source, which has just one of these, and a stereo file, which is what the low Atmos 2 is. And we can narrow the stereo file so it's more or less mono, or we can widen it out up to 180 degrees. And you see the spread there is telling us how far it's spread. If I go beyond 180 degrees, it goes minus 180 degrees. And that is essentially behind us. Because what binaural can do, it represents the way we hear as human beings. Now, we've only got stereoscopic hearing. We've got two sources. But because of these, all of our ears basically, we are able to tell whether a sound is above us or below us or behind us with just stereoscopic hearing. Very important if you're a hunter-gatherer trudging through the primordial forests of Stone Age Britain. It's really important to know where stuff is, particularly predators and threats. I've talked about this in the past. So we've got that. We can go from there to there. As you can see, we can move it. This is where we are, right at the center. This is our perspective. So any movement we do around here, it's from where we are. And that's the plane of view. And with mono, it's just a single sound, a single little dot. And you can decide how much stereo spread you have. So if we have it there, like left and right with a 90-degree spread, the closer I move to us, the narrower that sound gets, because as it would, if you're some distance away, the sound will spread across the whole spectrum you hear in both ears. But as we get closer to it, it becomes more and more specific. It gets narrower and narrower as we zoom in, and this also is how we would reflect certain shots. If a wide shot, we'd want the sound to be wide, maybe even wider than that, like so, like that. But as we approach that distant object, or the distant object approaches us, the stereo width gets narrower and narrower until when it's on us, it is one sound. And that's basically how we hear, and we can do it from various angles. It's great, it's just great. And that is distance. So what we've got angle, there we go. So angle to left or right. distance 1.2 meters. So that sound at its furthest point is 1.52 meters away. And can you see here, size 1.5 meters, that represents that. I think I've just gone beyond, so just there we are. And the spread is 128. I can go to 90, like so. And we have elevation as well, which is currently plus 8 degrees. This is this here. So at the moment we're on the stereo horizontal plane. So we're hearing the sound on a horizontal plane. But if you want the sound to lift the sound, we can just tilt this down. So the sound is now above us. Tilt them out 40 degrees. We can go up to, I don't know how far, 45 degrees. And then it really is. There we are. And that's, so we're listening to a sound that's coming from up there. For instance, tannoys or PA systems with speakers. Maybe we're in King's Cross Station and there are tannoy systems playing. Maybe they're playing slightly there, so we can tilt it. We can do all kinds of weird stuff. So you can play with that. What you can't do is automate that. You can set that, but you can't then rewrite that. You can rewrite all of this. And I'll talk to you about that when we talk about the actual mixing. Finally, the size. So I can move that up. It goes as far as 20 meters. So now that sound is 20 meters away. And this is very handy again. So for instance, your Atmos tracks, you might want to set it at, let's not say maybe not 20 meters, let's say 10 meters away. As the girl's moving around, and we can have, maybe sounds coming there and maybe some other sounds the other side or behind her. Remember, she is here. And we can pan as she turns. So we get dynamic sound. It'll make more sense when we do it in real life. I'm just demonstrating the functionality of this pan system. And 10 meters, the clown can be much closer. Should we decide to have the clown sounds binaurally or stereo? Not really sure. I think we'll go for the whole binaural thing. What the hell? And so the clown, for instance, the clown's voice will probably be quite static because we always see him in front angle when he's speaking or making a noise. His vocal track I'm talking about now, the clown voice, and it can be just further away or closer, and we can set that at maybe 2 meters. They can be, once you've mixed, you can alter those. You can make it, it's all a bit too close, we can just make it a bit further back. What you can't do is write that in. It's set and then that's it. Okay, so we've talked about the planar view. Yeah. Now we have something called the spherical view, which is like that. And that basically, this is our head. And so we can have movements going over our head, around, and so on. I don't use this very much, but it's all it does is affect the elevation. So you might be panning a sound closer to you on the planar, yeah? But then you can also bounce it so it also goes above elevation. This is the top of our head now, by 88 degrees, and then when it goes beyond us, it goes lower again. There is some functionality in that. Feel free to explore that. I don't use that an awful lot. I tend to use just the planar, and if I want the sounds to be elevated, then I will set that elevation. But spherical allows you to record movement in that sense. You're able to record those actions, whereas in planar you can just set your elevation and that's it really, and you do it through the use of that. So you can do both spherical and planar stuff on planar by using this. I just prefer to use that. It's very different mixing. We tend not really to use the volume in the input tracks as much as we did if we were mixing with stereo. What we would do is we would tend to set, I would tend to set the level. For instance, what's the loudest the low atmos is going to be? I would put the closest, I would have it there. Let's say that's as close as it gets. And then I would set my volume to the volume that I wanted to be when it reaches that loudest point in the design. And then I would leave it, because the rest is created through the movement here. This is just pan. This actually affects both the dynamics of the sound, the frequencies we hear the further away we are, and volume. So as I move this up, the volume gets louder without ever touching the volume control. And that is the basic introduction to the binaural panner. And everything's the same on this one, except you've just got the single mono source that you can move around. And of course you can record all of that. So in the next video, we'll be starting to set up our design to mix binaurally.